Hi. Yeah, I think we are live. So hi, my name is Richard. I am the head of DevRel at the IOTA Foundation, and I'm here with some lovely people from Goldsky. So um, here we go. So Andrew, do you wanna say hi?
How's it going? Yeah, we can wait a few minutes. We're just gonna let people hop on and get you guys settled in, situated. But we have a really awesome time coming up the next hour. We're gonna do some really cool stuff, showing you, what Goldsky is about, how you can make your, developer experience in IOTA much more enhanced. And yeah, we'll dive into it shortly.
Yeah, fantastic.
Cool. Well, if you're good with it, Richard, I think it's been a couple of minutes. We've kind of let people just settle in, hop
Yeah,
on, get comfortable, grab their water or coffee or whatever.
yeah,
And
yeah.
so we can kick things off if you're ready for that.
Nice one. Yeah, let's do it.
Sweet. Well, did you want to make a little intro, or did you want me to hop in? I can just take it from here. Up
Yeah,
to you.
Andrew, I'll let you take it from here. Thanks very much.
Perfect, perfect. Hi, everybody. So to kind of kick things off, just to give you a little bit of intro. So my name is Andrew. I am the customer success manager over at Goldsky. So what I do is kind of engage with ecosystems, talk to partners like IOTA, and just figure out how to make the developer experience a lot more streamlined and, educate people and really just kind of make it a fun, better, just optimal experience, right? So today wanted to just kind of give a high level overview of what Goldsky is and where IOTA fits into the equation, in case you're unfamiliar with, what indexing is, what Goldsky is, and where the pieces come together. So to just kind of take a step back and really dive into what at the core we're trying to solve here today. So when it comes to utilizing on-chain data, essentially you want to make sure that it's really, really fast if you're building an app that you want to have feel like a Web 2 kind of app, right? So if there's any kind of on-chain data that you either want to be displaying for analytics purposes, or you want to power an app where, there's on-chain events that trigger actions in your app, essentially you need to have really efficient data. And reading on-chain data can be very difficult if you're not the root of all of today is about. Indexing is essentially a way to take a look at on-chain data and really efficiently create these data structures that allow you to query for specific insights that you're looking for, whether it's a specific asset you want to watch or a chain you want to look at insights on. Maybe there's some wallets you want to track, right? Any kind of activity that happens on chain, if you're indexing it, you're going to be able to get that information in a much faster way. And it's going to be a lot more efficient, especially for whatever you're building out with your app, if you want to make it, more real time. So Goldsky, that's where we come in. We're essentially tooling that provides indexing infrastructure for developers. And there's a couple different ways that developers can utilize these tooling. There's something called Subgraphs, and there's something called Mirror pipelines. So initially with IOTA, we integrated with IOTA EVM, and there's Subgraph support where essentially, if you're unfamiliar with a subgraph, that's kind of like looking on chain with a magnifying glass, where you're creating this GraphQL endpoint that is pulling information from on chain and allowing you to query it really efficiently. So you can basically plug that endpoint into your app or into your dashboard or however you want to query that information. And subgraphs primarily are EVM only. So with IOTA EVM, it was just a natural fit, and we've been integrating that for quite some time. And now with the new launch of IOTA built on the Move language, it's really a very cool leap forward in innovation for this ecosystem. And it's changing the game because it's going to make the developer experience, very interesting and maybe faster, more efficient. So we're excited to see what kind of apps are built out. And this is kind of a great segue into what Mirror is, that second way that you can index with Goldsky, because since IOTA's new mainnet is now on the Move language, that is to Radek, who's our solutions engineer. This guy is a guru when it comes to Goldsky, and he's going to be touching
Andrew,
on.
I think I just had a network dropout for about the last 10 or 20 seconds.
Okay.
Apologies. So,
it was good on my side though.
Oh, was it? Okay, great. Yeah, but I think on the stream,
cool.
We may want to.
Yeah, no worries. I mean, I could just roll it back 30 seconds.
Yeah, cool.
So to give a little bit of recap about Mirror. So essentially, it's a technology that allows you to have a similar kind of data infrastructure where you're looking on chain and you're taking that information. But what's different is because it's the Move language, it's not something that Subgraphs can support, because Subgraphs typically tend to be EVM only. But obviously, indexing is still a very powerful tool because it optimizes how you're reading on-chain data. So that's where Mirror data streaming pipelines come in. And with this new IOTA Move language that it is based on, Mirror is kind of a really optimal solution here. And it allows you to put any kind of on-chain data into your database, whether it's Postgres, ClickHouse, S3, whatever kind of system you already have. You can kind of take that on-chain data, put it in there, and then query within there. So really efficient, real-time data, allows you to be flexible about how you combine data, whether it's multiple chains or off-chain with on-chain. And so it's a really cool way to, really leverage whatever's happening on-chain for your app. And without further ado, I'm going to pass it off to Radek. He's the Goldsky Solutions Engineer. And he...
Hi, Radek. I think the connection dropped out again slightly.
Oh yeah.
Yeah, I'll let you start your introduction. Thank you.
Yeah, no worries. Sure. Yeah. So my name is Radek, and I'm part of the technical services team at Goldsky. I'm working along Andrew, John, and Harvey, and our mission is pretty simple. We are trying to help developers and non-technical folks to get the most out of the Goldsky technology. And that's, everything. That's designing solutions, that's sharing best practices, or just being there if you hit a roadblock. So, before we start, I just wanted to quickly apologize, since it's my first time running a live workshop like this. And just because the first time you do anything is going to be rough, so please be patient and let me know what was missing, what's working, what's not working. And also don't hesitate to interrupt with questions along the way. If something is unclear, then let me know and I will try to elaborate on it. And if you have any questions I cannot answer on the spot, no worries. I will take them to the team and follow up. But for general support, shoot us at support@goldsky.com, and this way we can load balance the ticket and get you the right person on your case as quickly as possible. All right, let's dive in. So here's what we're covering today. Think of it as the evolution story of the blockchain data processing. We'll start with the why indexing even matters, why it matters when you're building for IOTA or any blockchain really. I will show you how developers used to struggle with this stuff, and spoiler, it wasn't pretty. We'll touch briefly on subgraphs. They are important context, but today's star is mirror pipelines. That being said, for the sake of completeness, I will cover subgraphs as well. And of course, we'll build something together at the end of the presentation, because who doesn't love seeing things breaking in real time, right? So feel free to drop questions in the chat anytime. Like I said, this is meant to be interactive, and let's start. So let's start with reality check. Blockchains are amazing for many things, but reading data from them, that's unfortunately where things get messy. So consider this. IOTA Rebased is churning out checkpoints, transactions, events, basically tons of data every second. Each checkpoint contains transaction. Each transaction contains multiple move calls, and each call might even emit extra events. So we are talking potentially hundreds of data points in just single checkpoint. And now just imagine you are building a DeFi dashboard and need to show user transaction history. Without indexing, you would be in huge pain trying to build this. So how did developers originally tackle this? The old school way was to call the RPC directly. And if we wanted to show some quick real example, you can have a look at the code snippet. And let's say we want to display small collection of 20 NFTs using just direct RPC calls. And guess how many network requests that would require to fetch 20 NFTs? Feel free to drop your answers in the chat. But yeah, so the answer is 41. For 20 NFTs, we would have to make 41 RPC calls just to fetch the NFT data. And that's not even counting client-side decoding, that may be optional, and also fetching the data from the IPFS. So if you get the data from the smart contract, you will get the URL to IPFS, but then you will have to also fetch the image, the traits, etc. So that's even more, and yeah, that's kind of crazy, right? So yeah, think about what this means for your users. They are sitting and trying to do something with your app. They are watching Spinner, wondering if your app is broken. Meanwhile, you're hammering the RPC nodes with requests. Your infrastructure costs are going through the roof, and you haven't started building the real features yet. So yeah, that's definitely far from ideal. To give you more real example, you can think of it like trying to find a specific conversation in your message history by reading every single message from the beginning. Sure, it works, but there's got to be a better way, right? And we are entering indexing. So the better way we've been all looking for. You can think of indexers as blockchain scrapers or specialized search engines for blockchains. And just like Google crawls websites and organizes the information for quick retrieval, indexers continuously scan the blockchain and structure the data in a way that makes sense for your application. Yeah, so instead of asking the blockchain, show me every transaction that there is, and I will figure out which one I need, you can now ask, show me the last transaction for this user. So as you can imagine, this is a huge difference, both for users, but also for developers. Today, pretty much every Web3 app is powered by indexers. As you can see on the screenshot, there is IOTA Explorer showing some real-time metrics, and that's definitely powered by indexer. We are surrounded by apps that are powered by indexers. Your favorite DeFi protocol tracking prices or liquidity, that's definitely an indexer. Or NFT marketplace when you can search instantly, that's definitely indexer. Yeah, so without indexing, Web3 would feel more like Web 0.5. So it would be technically functional, but practically unusable. Now let's talk about subgraphs. They are kind of like the iPhone of indexing, not the first, but definitely the one that made it mainstream. And here is the deal. Subgraphs watch your smart contract. They catch events and store everything neatly in Postgres. On top of that, there is GraphQL API that you can use to query your data. It's simple, pretty elegant, and just works. At Goldsky, we took this open source subgraph tech and basically turbocharged it with some cool and fancy features. We can definitely say it has much better performance. It has rock solid reliability and features that just make developers' lives easier. And also important thing, this is all while keeping it 100% compatible with the graph original graph nodes. So if you ever want to migrate your subgraphs, then it will be totally seamless experience. One caveat regarding subgraphs, though, that Andrew already mentioned, subgraphs are for EVM. So subgraphs were built in the EVM era for EVM chains. So while you can't use for non-EVM chains, you can't use subgraph for non-EVM chains, you can totally use them for IOTA EVM. Right, so let's talk briefly about the limitations as well. So first, subgraphs are processing data in sequential manner. So they are processing one block at a time. So when you're dealing with high throughput chains that needs like real-time performance, and you need really high processing power, then this approach may become a bottleneck. But there is a solution to that I will cover later. And answering potential questions, while you can optimize subgraphs with better hardware, with caching, some query tuning, the fundamental architecture behind subgraphs is forcing it to process data in sequential manner. So there is no much room for horizontal scaling or parallel processing capabilities. That being said, for many use cases, subgraphs are really great. They are a great piece of technology, and you totally can rely on subgraphs if you are building for EVM chains, indexing for later. So we covered the performance issues, but there are other walls that you will hit with subgraphs. So first of all, GraphQL isn't a data warehouse. If you need to run analytics or calculate historical trends, maybe do some complex aggregations, GraphQL isn't built for fetching entities. By the way, so if you end up with GraphQL and you want to use, for example, Elasticsearch for fuzzy search, or ClickHouse for analytics, or data lake for machine learning, then you are kind of stuck in a route trying to build ETL pipeline on top of it. So yeah. And plus, there are no streaming capabilities. So modern apps need real-time updates. You can think of price alerts, transaction notification, or maybe some liquidation warnings. And GraphQL requires pooling. So why this is possible, that adds bandwidth and latency on top of your subgraph if you want to, on top of your app, if you want to use it. So as I mentioned earlier, our subgraphs are Goldsky are turbocharged, and we provide similar mechanism for that in form of webhooks. But that's just us, and you won't find it in other approaches. So yeah, these aren't edge cases. These are standard requirements for production. So what's the answer for that? The answer is Mirror, and this is why we built Mirror. It's indexing evolved for the real world. We believe at the end of the day that all roads lead to the modern data pipelines. Instead of being logged into one API endpoint, Mirror lets you stream blockchain directly to your desired sync. So for example, as I mentioned earlier, you need blazing fast search, stream it to Elasticsearch. You need to run some complex analytics, you can pipe it to ClickHouse. Or if you want to mix your data with your user data, sure, you can pipe it straight to your Postgres. So yeah, think of it as having a data fire hose that you can point wherever you need it. And another important piece is that parallel processing and horizontal scaling is huge boost here. I mean, mirror data pipelines are by nature working in parallel fashion. So while subgraphs process one block at a time with a single worker, with Mirror, you can spin up as many workers as you want. So you can spin up 10 or 40 workers, and whatever it takes to keep up with the throughput or backfill your data quickly. Mirror also gives you complete control over your data flow, so you can stream to your destination of choice. You can also transform data in flight. You can filter out any noise, any records that you don't want to trash your database with. You can enrich the data with additional context and with the use of so-called external handlers. And this is all while maintaining real-time performance. So before we dive into the demo, let's quickly look at what IOTA non-EVM gives us to work with. So we have checkpoints. You can think of these as periodic snapshots of the network. And there are also epochs, which are time periods where validators do their thing, basically. This is super useful for staking analytics. There are events, so every time a move module emits an event, we capture it. There are move calls, so we track every function call. And there are transactions, so the full transaction data. All right, so it's showtime. Let me try to switch screen I'm sharing. All right, so here you can see Goldsky platform. Here exactly is pipelines section. We can start building the pipeline right away. So let's click on new pipeline, and the mirror pipeline canvas will pop out. And as you can see, you have few blocks, different kind of blocks here to use as your building blocks. So we will start with the source. So you can choose any source you like. We support hundreds of chains. Let's start with IOTA non-EVM. Here is called IOTA rebased. And we can now select from our desired database. So let's go with move calls. I have simple demo example in mind. Okay, we can also specify whether we should start indexing at the beginning or current checkpoint. So either from block 0 or checkpoint 0, or from the edge, from the most recent checkpoint. We'll go with the beginning. If you click on View Schema, you can also see what type of data you can expect from each dataset. Here you can see there are few columns like transaction sequence number, epoch, move package, move module, etc. And here is some exemplary data. All right, so having that, we can go to the next piece, which is creating new block, new part of our ETL pipeline. We can choose from custom SQL, HTTP handler, and sync. So sync we will leave for the end, where we will pipe our data, but I will briefly talk about HTTP handler because it's super neat. It allows you to call external service, for example, AWS Lambda, that will enrich the data and return it. Then you can process this data further and this way stream such transform data into your pipeline. So yeah, this is pretty neat. Let's go with custom SQL. I already prepared some simple SQL so that I don't trip during typing, and you don't have to watch me trying to fix the issue for next few hours. So let me copy paste it. So basically, this is simple piece of SQL which allows you to take a few columns from the data set. So we will take transaction sequence number, move module, move function, and epoch. Then we will filter out all the records based on the move function name. So if the move function contains swap or liquid or stake or claim, then we want to process this data. And in this case, we will map it accordingly. So maybe it's a bit unpractical, but for the demo purposes, to make it more eye-pleasing, I will map. I will map move function to action, which will be described with emoji. Let me check the messages. Oh yeah, I will turn off the camera so that we will have better streaming stability. Right, should be better, I hope. All right, and back to it. So I will also copy transaction sequence number. It will be handy to just copy paste it here. I'm pretty lazy when it comes to this stuff, and this will be used as our primary key. So another thing that we should do to make it more nice and clean, we can call it calls, for example. And here you can see we reference this data set in this exact line. All right. Also, the binding has been created automatically, as you can see. Right. So we are approaching the last part, which is creating a sink. So when it comes to sinks, as I described earlier, you can choose from many sink types. So you can choose DynamoDB, you can choose S3, SQS, Kafka, Webhook. There are plenty of choices. For the demo, we will try pretty new feature we released some time ago, which is hosted databases. So instead of bringing your own sink, we can provision the database for you. We will also automatically scale it and maintain it, so you don't have this maintenance headache on your end. Let's call it just hosted Postgres. We will create the thing. It's almost there. Data is being provisioned, and we will be ready to use it. All right. We also got the connection string and PC call because the database is maintained by us. However, you have full control and full access to this database. So if you wanna access this database, do some changes, or use it for your purposes, then you are totally free to do so. I will copy it for later, and we will use this in later stages. All right, as you can see now, the connection is created. Here are a few tweaks you can make. Basically, they can be important if your throughput is lagging behind, or you wanna probably speed up some backfilling. Then you can play with batch size, with batch flash interval, and other stuff. But basically, it's not usually important for most use cases. Here we will also rename the table to calls, and this way we are all set. let's go to the next step, which is deploying the pipeline. So here is also one important thing, which is resource size. As you can see, we have many resource size types here. There are small, medium, large, etc. For most cases, I would say start with small, and for many use cases and for high throughput chains, it's totally fine. The small instance is super powerful, and if you see it's lagging, then you can always scale up or scale down. So there is no problem with that. Oh, last thing, we should rename it as well. And we are ready to go. All right, so while the pipeline is being deployed, I can briefly go over the dashboard you can see here. So you can observe metrics such as records received and records written. However, you should know that it's not like one-to-one. You can receive like millions of records, but write just a few thousand. As you will see in this example, we filtered out many records based on the move call name. So I'm expecting to process all the blockchain data, however, write just a fraction of it because I'm filtering out most of it. Another super important and helpful piece is a logs component. So as you can see here, you have access to full observability, in a sense that you can use it to troubleshoot issues on your side, but maybe on our side as well. And yeah, this will be super helpful to just see whether everything is going fine. Sometimes maybe your webhook becomes unresponsive, and you can see in the logs that it's returning some 500s or something. So yeah, we already see that the table public calls has been created, and the pipeline also is starting. And the last but not least is this YAML definition, because while I was showing you everything on Goldsky website, you can do everything through CLI. So you can manage all your pipelines or your subgraph things sources through CLI. I will show you in a sec, but for now, let's have a look here. All right, so as you can see, we already received over 5 mil of records and written almost 50K. Let's try to connect to the database. I will switch screen to show you my terminal. Where it is? One sec, sorry. All right, I got this. You should see my terminal right now. So maybe you remember I copied the connection string to the database. So now we can use terminal to connect to it. And let's list the tables. As you can see, there are calls. Let's have a look at the table. Yeah, so here it is. We have our table filled with data. We can see mostly or just stake action type, but let's see what other action types are there and how many of them. So maybe we'll do count and action type. We will group by action type. Oh yeah, cool, sweet, yeah. So everything seems to be working. We have like 50K of stake related move functions. some swaps, liquidity, and claim. However, don't treat it as like production grade pipeline. This example, don't treat it as production grade, because it was pretty naive of me to just try to match whether the move function was of type stake or swap or liquidity. It was kinda rough to match it this way, but yeah, I just wanted to show you example, and I hope I did it well. Let me switch quickly to another window. All right, so now you should be able to see the code editor. Here I copied the YAML definition you've seen before in the platform, and now I'm going to show you how you can use CLI to operate your pipeline. And this is super neat feature, because you can connect your CI/CD steps. I mean, you can add extra step in your CI/CD, and for example, deploy your pipeline automatically. Yeah, so we can change something. So to show you how simple is that, let's just bump up the resource size and just go with that. We can type Goldsky pipeline. By the way, you can use many commands here. As I said before, CLI allows you to fully operate the subgraphs, pipelines, sources. And yeah, so for example, if we do Goldsky pipeline list, we should be able to see all the available lists. And yeah, let's go with it and update the pipeline. So we have to also do one thing. So I forgot to also upgrade, bump up the version number. So it was 1, now it will be 2, so it should be detected as new version. All right, config has been validated and the changes are being applied. Cool, sweet. We can switch back quickly to the dashboard. And as you can see, we are seeing, you are viewing an older version of this pipeline. Let's see latest version. And as you can see, we have second version of this pipeline that is starting. And here is a cool part, which is here is from snapshot, and this means that the pipeline won't start from scratch. It will start where the previous version has stopped, so you won't have to process all the data over again. This is by default. If you apply changes, by default it will create snapshot and run from the latest snapshot. However, you can specify on your own which snapshot should be used, or maybe none of the snapshots should be used, and you want to scratch from the very beginning of the blockchain. So that's also possible. And yeah, that's what I wanted to show. There's also another cool feature I'd like to briefly go over, which is having multiple data sources. So just to show you, you can have many data sources within a pipeline, and you can build separate pipelines. But what's cool, you can bind them together. So for example, you can have SQL transform that will be using both sources. So for example, calls and sources, and then the data will be joined like you would join tables in SQL. So here we are using Flink under the hood, and with Flink SQL you can still join tables. And yeah, so that's pretty neat. I hope that shows how cool building with Mirror pipeline is and how much you can do. It's really easy. If you want to give it a try, then feel free to head out to goldsky.com and start playing around with that. Cool. So are there any questions maybe? Okay. If not, then let's bring it home. So today we've seen how blockchain data evolve from painful RPC calls to pretty neat subgraphs to very modern and powerful mirror pipelines. The key takeaway that I want you to take with you is that your data infrastructure should grow with your application. So you can start simple with subgraphs if that works for you and you're building for EVM. But if you need something more powerful, then you should know that Mirror is there, and it will provide you with as much power as you need. Lastly, as IOTA devs, you are working with cutting-edge tech, so make sure your data stack is equally cutting-edge. Also, feel free to go to this link and leave some feedback. It will greatly improve next sessions. Cool. And I'm leaving some useful links. I will share the presentation after the call so you can check it out.
Hey, Radek, quick question I saw in the chat. Gino was asking, what truly differentiates Mirror from other blockchain indexing or data streaming solutions out there? Is that something you think you can dive into?
Right, yeah. So I'm still pretty new to Mirror pipeline, but I can say that Mirror pipeline is very performance optimized. And as I show you before, you can scale your infrastructure almost infinitely. So you can upscale, you can downscale. Also, this is pretty host friendly. You don't have to worry about some hefty billings. Additionally, the Mirror pipelines are super great for real-time processing. So if you are really keen on streaming data to your app in real time, then Mirror pipeline really shines. So like I said, horizontal scalability. Also, what differentiates us from the others is also multiple types of destinations. So like I said before, you can stream your data to Elasticsearch, to ClickHouse, to S3, to Kafka, to SQS. So there are many, and the list is still growing. So I believe it's super important to also emphasize the external handler capabilities, because while this is all cool and you can process the data, it's sometimes super important to also enrich the data in some way. So for example, to call some price feeds, to enrich the data with the prices. So with the external handlers, you can use AWS Lambda or any other service and just enrich the data the way you like and return in a shape you like. So I believe that's pretty powerful.
Awesome. Well, I think that definitely answers that question. Anybody in the chat, if you have any other questions, feel free to drop them in. Doesn't seem like there's any others, but if you ever do want to connect with our team, feel free to just reach out anytime. You can either interact with us on X. We're definitely on there all the time trying to engage with people. You can also reach out to us if you want to contact us directly. It's support@goldsky.com. That's where we can help with any really specific technical questions, or we can dive into topics if you want. Also, I'll throw in the chat on the YouTube chat my personal Telegram. It is at Andrew Gelman. Just dropped it in there. So if you want to reach out to me directly, just chat about what you're building. If you're a DApp and you want to connect with our team, if you're just an individual developer, you want to ask some questions, feel free to reach out. Yeah, I mean, we always enjoy talking to people so that we can kind of, understand what it is you're building, what some of the pain points you have are, and how we can help out. But other than that, I believe that kind of is it for today. We can wrap things up.
Yeah. Well, awesome. Cheers, guys. Thanks for that so much. While things are being plugged, I'm going to say from the IOTA side, if people want to come and visit us in the IOTA Builders Discord, we'll be happy to say hi and talk about anything you want to talk about in there as well. But Radek, brilliant. Thank you so much for that. And Andrew, it's been brilliant. So cheers, guys.
Yeah.
Thanks
Great job, Radek. And thank you, Richard. Appreciate you putting this together. Shout out for awesome workshop. So yeah, hope everyone enjoyed, and we'll catch you online.
That's great.
Awesome.
Cheers.
Thanks, guys. Take care.
Thanks very much.
See ya.
Cheers. Bye, everyone.
See ya.